Hello, my name is Cornelius Carrier. I will be presenting my Planck's constant project. For my topic, I chose topic E, symbol E. E represents energy in a Planck's equation. E equals hf and is described as the energy of a single photon, a tiny packet of light. This relationship shows the energy depends on the frequency of radiation. Higher frequency light carries more energy than lower frequency light. Scientists use this concept to explain and calculate phenomena such as photoelectric and affect quantum energy. Related fields about Planck's constant. Material science studies light-matter interactions and quantum effects in materials. Nuclear particle physics calculates energy in nuclear reactions. Electronics and semiconductor physics keys in photoelectric affect solar cells and photodetectors. Optics and photonic designs, lasers, LEDs, optical communication systems. And for my scientist, I chose Louis de Broglie. Louis was born on August 15, 1892. He later died in 1987. He was a French physicist who proposed that all matter exhibits wave-particle duality, a cornerstone of quantum theory, which he won in 1929 Nobel Prize in Physics. His contributions proposed that particles like electrons have wave properties, not just light. He introduced the idea that momentum and wavelength are related. His work helped explain electron diffraction experiments. He came from a family of scholars. His brother was a historian. His ideas bridged classical mechanics and quantum physics.
Okay, good evening, y'all. My name is Gavin Edwards, and I'll be covering Planck's constant today. The picture is me. I'm Gavin Edwards. The rest of my classmates will hopefully join me later. So for the introduction for the basic facts over Planck's constant, we have the symbol of H, which represents Planck's constant, with the value of 6.62, 60, 70, 15 times 10 to the negative 34 is the value. It is one of the fundamental constants of nature, meaning it does not change anywhere in our universe. It was discovered by Max Planck in the 1900 when studying blackbody radiation, which is the electromagnetic radiation emitted by a black body that re-emits a spectrum based only on temperature. Basic definitions of the topic: Planck's constant H, which is a physical constant that relates the energy of a photon to its frequency. Formula is energy equals Planck's constant times frequency. E equals hv. Reduce Planck's constant H divided by 2n often is used in quantum mechanics equation, which is very prevalent. Basic background: Planck introduced the idea that energy comes in discrete packages, quanta, not continuous waves. This was the birth of quantum mechanics. Helped explain why classical physics failed to describe blackbody radiation or the ultraviolet catastrophe, and then paved way for Einstein's photoelectric effect explanation, which showed light behaves as both a wave and a particle. Related fields: specific fields that use Planck's constant. Quantum mechanics defines energy levels and wave functions. And uncertainty: H is everywhere. Nuclear physics explains nuclear energy levels, particle interactions, and decay processes. Biochemistry and molecular biology uses spectroscopy to study molecules, infrared, NMR, fluorescence, and others. Electronics, it's used in semiconductors, LEDs, lasers, and superconductors, and more. Astronomy and astrophysics explains radiation from stars, cosmic microwave background, and black holes, which is a very big deal. Areas do not use Planck's constant. Classical mechanics, Newton's laws, momentum, force, motion of microscopic objects. Classical thermodynamics, heat engines, Kennett cycle, and large-scale energy transfer. General math, statistics. Why the fields use Planck's constant and why they need it. Quantum mechanics. Planck's constant sets the size of the quantum. Without it, we can calculate discrete energy levels. Biochemistry. Molecules absorb and emit photons. And Planck's constant links frequency to energy. Nuclear and particle physics. Planck's constant shows the relationship between particle energy, momentum, and wave-like behavior. Electronics / solid state. Planck's constant explains band gases, conductivity, and why modern electrics function. Astrophysics. Planck's constant explains stellar radiation and quantum processes inside stars. A relevant scientist to Planck's constant is Niels Bohr. Niels Bohr, he was born on October 7th, 1885 in Copenhagen, Denmark, and later died on November 18th, 1962 in Copenhagen. He received a Nobel Prize for his work as applying the quantum concept, which restricts energy of a system to certain discrete values, which is the problem of atomic molecular structure. His father was nominated for the Nobel Prize twice. He had 6 sons with his well-advised life, who he trusted and loved very deeply. And their 4th son shared the 3rd Nobel Prize in recognition of the atomic nucleus model. For his educational facts, he studied physics at the University of Copenhagen, earning a doctorate in 1911 for physics and a dissertation in electron theory of metals. He worked with Ernest Rutherford in Manchester, which influenced the atomic research that the nucleus as a heavily positively charged nucleus with lighter electron negatives. Became a professor at the University of Copenhagen and founded the Institute for Theoretical Physics, later renamed after him the Niels Bohr Institute. The research topics: use Planck's constant to propose that electrons move in quantized orbits around the nucleus, developed the Bohr model of the atom in 1913, which explained hydrogen spectral lines, contributed to the foundation of quantum mechanics, later worked on a nuclear physics, and was a key figure in international scientific cooperations, which I'll get into later. Fame. For fame, he won the in 1922, the Nobel Prize in Physics for his work on the atomic structure, recognized as one of the founding fathers of modern quantum theory. This model is still taught today as the first step toward understanding atomic physics, remembered for the Bohr-Einstein debates on the nature of quantum mechanics.